An axial pull of 20 kilonewton along with a shear force of 15 kilonewton is applied to a circular bar. The elastic limit of the bar material is 230 megapascal. Factor of safety is 2 and the Poisson's ratio mu is equal to 0.3. See, Poisson's ratio is not useful everywhere. Here also we will not be using this data. This is a superfluous data, additional data that is given. Determine the diameter of circular bar based on maximum shear stress theory, maximum principal stress theory, right? So using these two theories, you have to determine the diameter of the bar. Now let us start solution. Given axial pull, I will call it as P, is equal to 20 kilonewton. Then the shear force is F is equal to 15 kilonewton. Elastic limit is SYT is equal to 230 megapascal. Factor of safety FOS is equal to 2. Factor of safety you can call it as FOS, or some books they use lowercase f. So different notations are there. So I have just kept it as FOS. You can choose whatever notation you want. Now first let us find the stress components that are induced in the circular bar. First let us consider the tensile stress induced in bar. So let me call this as sigma T. So sigma, or I'll just say sigma. Let us not call sigma T, because sigma T is something different. Sigma is equal to load by area. Now what is load? Load is just load. By area is pi d square by 4. So pi d square by 4. 4 will go to the numerator, right? So 4p by pi d square. Now let us substitute the values. I do not have d, so it will be something divided by d square. So this will become 4 into P is 20 kilonewton. So 20 into 10 raised to 3 by, this will be same, pi d square. So this is equal to, now let us calculate this, 4 into 20,000 by 5. So it is 25464.8. Just copy this. .8 by d square. This will be megapascal, because I have put force in Newton and area in millimeter square. So the stress is in MPa, megapascal. Now there is also shear force. So shear stress induced in the bar that will be tau is equal to F by A, right? Force, shear force by cross-sectional area. This is direct shear force. This is not torsional. So it will be 4 times F by pi d square. I will just copy this entire thing here. Shear force is 15. So 4 into 15 into 10 raised to 3 by pi d square. So 15,000 into 4 by pi. So 19,098. 19,098.6 mega by d square megapascal. Now using this sigma and T, I can calculate the principal stress. Now maximum principal stress, maximum principal stress is denoted by sigma 1. So sigma 1 is equal to sigma by 2 plus root of sigma by 2 whole square plus tau square. We have derived this equation in the previous section. Now we will just substitute the values as sigma as this and tau as this. So just copy this, or sigma 1 is equal to, now put sigma as this. So it is sigma by 2. So we'll just put this and make this as 2d square. Okay, and this will be same. And tau is this. So this is tau square. Now let us just calculate this. This by 2 is this much, plus I am doing this term 19,098.6 square plus this square is equal to this much and square root of that. So it is 22953.7. 22953.7. So that is equal to, I'll tell you why I'm doing this step by step. So this is the maximum normal stress. Okay, so this entire thing by d square is there. Right? So this by d square and here also it will be by d square megapascal. This is the maximum principal stress. Now we have to find the minimum principal stress. So minimum principal stress, the equation is same. There is only one small difference in this. So sigma 2 is equal to sigma by 2 minus of root of sigma square by 2 plus tau square. So I'll just copy this entire thing. So sigma 2, the values are going to remain same, only this will become negative. Here this will become negative. That's it. Right? The bracket, the term inside the root will also be same. So let me just calculate this. So this is negative. So negative means it is compression. So minus 10221.3 by d square megapascal. Right? This is the maximum principal stress. Now let us calculate maximum shear stress also. Now what is maximum shear stress? Tau max is equal to sigma 1 minus sigma 2 by 2, or just put that sigma 1 minus sigma 2 by 2, right? So let us put the values. This is equal to sigma 1 is this by d square. So I will just put it there, minus sigma 2 is minus, right? So I'll just put this in a bracket. So minus of minus, it will become plus by 2 times d square. So this will be this plus this by 2. So it is by d square megapascal. Now I have maximum principal stress, minimum principal stress, and maximum shear stress. Now I can find the diameter according to these two theories. So first he has asked maximum shear stress theory. So I'll just write one. Diameter of bar based on maximum shear stress theory. Right? Now what does maximum shear stress theory says? The tau max should be less than or equal to SYT by 2, right? So let us do this. We have tau max is equal to now he has given the elastic limit of the bar material is 230. Now this is for simple tension, so there will be only sigma, there is no sigma 2. So in that case tau max will be sigma by 2. So it is 230 by 2. So tau max is equal to S, or I will call this as SSY, that is better, SSY is equal to SYT by 2. SYT is 230 by 2, so this will be 115 megapascal, right? Now permissible shear stress in the material tau is equal to SSY by factor of safety. So SSY is 115 by factor of safety is how much? 2. So this is equal to 57.5. 57.5 megapascal. Now this is the maximum shear stress that can be induced in the material. Beyond this, according to this theory, the material or the component has failed, right? So therefore tau max I'm just equating tau max to 57.5. So this is equal to 57.5. Now from this I can find D, or D is equal to 22953.7 by 57.5. This is D square, so take root of this, 19.98. Just leave it like this, no need to round off or do anything. Now the same thing I have to calculate based on maximum principal stress theory. The diameter of bar based on maximum principal stress theory. Now what does maximum principal stress theory says? The maximum principal stress here is sigma 1, and that should be less than or equal to sigma t. So permissible tensile stress sigma t, right, is equal to SYT by factor of safety. SYT is 230 by factor of safety is 2, so this will be 115 megapascal. This can be the maximum stress. Now for failure sigma 1, where is sigma 1? Sigma 1 should be equal to sigma t, right? Actually it should be greater than or equal to just taking it as equal, or I will substitute the values now, or this is equal to 115, or B is equal to how much? Now let me just copy this. This by 115 is this. This is d square. Root of this is 17.62. 17.62 millimeter. Right? So based on shear stress theory, the diameter we obtained is 19.98. So it's almost 20 mm. And based on maximum principal stress theory, we got the diameter as 17.62 millimeter, right? So this is the answer for this question. Is there any questions or doubts on